guys, today we're going to do some factorisation. This is exercise 4b and we're going to start with question 2l. And the question is that we need to factorise 8x squared y squared plus 6y squared x. So the first thing I would do is to take out the highest common factor of 8 and 6. So that would be 2. I'm still left with x squared y squared and y squared x. And now so I want to find the highest common factor of x squared y squared and y squared x. So we can see there that the x's, there's one that's squared and one that's just to the power of 1. So I can take out just one x there. And for the y squareds, they're both to the power of 2. So I can take out y to the power of 2. So I take out xy squared. I then just factorise by taking out the highest common factor of 2xy squared out of the brackets, which leaves me with 4x plus 3. What we can see here, if we check, we can see that 2xy squared times 4x gives us 8x squared y squared, which is what we want. We can see that in the original question. And 2xy squared times 3 gives us 6xy squared, which is the same as 6y squared x. We can do that on CAS, and how we do that is once we are in the menu, we select main, and we just type in our question there, 8x squared y squared plus 6y squared x. There it is there. We then go to the interactive menu, so we click on that. We go to the transformation, and then we go down to factor. If you click on factor and press XE there, then you're going to get your answer of 2xy squared for x plus 3. And there we have it. That's how we do it on CAS. Let's do another example. This one a little bit different. We've got x cubed minus bx squared minus a squared x plus a squared b. It's got 4 terms in it, so we want to try and group it in twos. Notice that sometimes they'll be in order and sometimes they won't be in order. This one is in order. So we can look for the highest common factor of x cubed and negative bx squared, and that would be x squared. So if we take an x squared out of the brackets, we're left with x minus b. Let's now look for the highest common factor of negative a squared x and positive a squared b. And the highest common factor there would be negative a squared. Notice I do need to take out the negative as well. That leaves us with x minus b. Notice that for the first set of 2, I've been left with x minus b, and for the second set, I've been left with x minus b. So now we're left with x squared times x minus b minus a squared times x minus b. We're not there quite yet. Let's continue. So far we've got x squared, open bracket x minus b, minus a squared, open brackets x minus b. Let's pretend that x minus b is m. So it's going to look like this. And when it looks like that, you just have to think of what you would usually do. We have an x squared m and a negative a squared m. There's m, which is the highest common factor there. We can take that out. So we have m, and we're left with x squared minus a squared. Now, that's not the final answer because we didn't have an m in our original there. We can't just make up an m. We've just used that to help us out. So now we have to say, well, m is actually x minus b. So we put the x minus b in the place of m, and we're left with x squared minus a squared. What we can do with that is to factorise that to x minus a, x plus a, and that's our final answer. We must not forget to fully factorise. So at this step here where we have x minus b and then in the second bracket x squared minus a squared, we're not quite there yet. We do want to make sure we've fully factorised that x squared minus a squared. Let's now do one which is 4x squared minus 81. This expression has 2 square root things in it. So we have 4x squared and we have 81. There's a rule that we have for this, and that rule is a squared minus b squared equals a minus b in brackets, and then the next bracket's a plus b. That's just a rule that we need to know. It's the difference of perfect squares. We can then identify what a and b actually are. So in this case, a is 2x. Notice that I have to find the square root of the whole of the a term. So not just the x, 4 has to be square rooted as well. That gives me 2x. For b, the square root of 81 is just 9. So b equals 9. I then just plug it into the rule. So a minus b would be 2x minus 9, and a plus b would be 2x plus 9. Let's do another one like that, which is the same idea of a squared minus b squared, but it's got something a little bit more tricky looking there. Let's see, we've got a squared, so we identify the rule being a squared minus b squared equals a minus b, a plus b. Let's identify a and b. So for a, we have 5 because the square root of 25 is just 5. For b is this whole thing here, 2 plus x, which is squared in our original. So b is 2 plus x. Let's put it into the rule. So a minus b would be a plus b plus 2 plus x, and a minus b would be 5 minus, in brackets, 2 plus x. In this one, I've done the addition first. It doesn't matter whether it's a minus b, a plus b, or a plus b, a minus b. Notice here how we've got this negative in the 5 minus 2 plus x. This is where people will stuff up. I've put it in brackets here because I want to make sure I subtract the 2 and I subtract the x. Most people will just subtract the 2 and then add on the x. Be careful of that. I can then simplify that by saying 5 plus 2 is 7 plus x in my first brackets, and 5 minus 2 being 3 minus x in my second brackets. Don't forget that some examples won't be so neat like this. Let's do one where we have 3 terms. So this is question 5A from exercise 4B. So in this example we have 3 terms. The way we can do it is to cross multiply. So I say, how do I get to x squared? I say x times x. I then want to see, how do I get to negative 18? And this might take a few trial and errors. So you think of all the factors of 18 and negative 18 rather, and you find one that when you say you cross multiply, so x times 2 is 2x and x times negative 9 is negative 9x. When I do that, 2x minus 9x gives me negative 7x, and that is my middle term. So then I can say in my brackets, I'm going to have x minus 9 and x plus 2. I read crossways like that. Don't forget to keep checking on CAS. Let's do one that's a little bit harder. The same type though, so this is question 5H. So here we've got 3y squared minus 12y minus 36. I'm going to take the 3 out of the brackets there. It just makes it easier. You can leave it, but it's easier to take it out. That gives me 3y squared minus 4y minus 12. Let's cross multiply. So negative 6 times 2 gives me 12, and y times y gives me y squared. Let's see if we can get to our middle term. Y times 2 is 2y, y times negative 6 is negative 6y. That gives me negative 4y, which is the middle term once I've taken the 3 out of the brackets. So that's correct. Don't forget that when you put your final answer, you're going to need to put that 3 in. So I've put that 3 outside the brackets there. Often people will forget that, so they'll lose marks there. Y minus 6 in the first brackets and y plus 2 in the second brackets. Another one like that is 5O, and this one looks a little bit complicated, but isn't really. We've got x minus 1 squared plus 4, x minus 1 in brackets, plus 3. Let's call x minus 1 m. So now we can write it out as m squared plus 4m plus 3. And you can see that's really easy now, because when we cross multiply 3 times 1 and m times m, we get m times 1 is m plus m times 3 is 3m equals 4m. That's our middle term here. So our brackets would be m plus 3 and m plus 1. We're not finished yet because m was nothing to do with our original question that we were going to factorise. We have to now put x minus 1 back in the place of m. I'm going to put in brackets just to make sure I don't leave out any negatives. So x minus 1 plus 3 and x minus 1 plus 1 we get in our brackets. Let's collect like terms. We get x minus 1 plus 3 is 2 and x minus 1 plus 1 is 0. So we get x from here because the negative 1 plus 1 is cancelled, and x plus 2 from the first one there. So the answer is x times x plus 2. Keep shaking on Cass, and that's it for today.